AP Style Free Response Problem 9. Part A, use the trial 1 data plotted in the graphs, so these are graphs from data taken during a first trial, to determine the order of the reaction with respect to C4H6 concentration. B, the initial rate of the reaction in trial 1 is 0.0010 molarity per second. Calculate the rate constant K for the reaction at 625 Kelvin. All right, so in part A, we're going to use the data that we plotted on the graphs in trial 1 to determine the order of the reaction with respect to C4H6. So let's look at our 3 graphs. We have concentration with respect to time, natural log of concentration with respect to time, and 1 over concentration with respect to time. And what we're looking for is the one that has the linear relationship. That would be this third one right here. Now, it's not enough to just pick out the one with the linear relationship. You have to know, what does that tell you about the order of the reaction? So you have to know that when a graph of 1 over the concentration versus time is linear, that means this is a second order reaction. So the rate law is equal to R equals K times the concentration of C4H6, and then of course squared, because it's a second order reaction. All right, in part B, now that we know the rate law, we're given some initial information. We're told that the initial rate means at time 0. In trial 1 is 0.0010 molarity per second. Calculate the rate constant K for the reaction at 625 Kelvin. So we're going to take our rate equation and solve it for K, and then substitute the initial reaction rate and concentration from trial 1. So we need the initial reaction rate and the initial concentration. Okay, so here's our rate law from the previous step. We rearrange it to solve for K. Now, we are given the initial rate of 0.0010 molarity per second. 0.0010 molarity per second. Where does this 0.02 molar come from? This is the initial concentration. So we have a graph here that's concentration, and we can just read what is the concentration at time 0. It's 0.020 molar. Now, you could have also used the third graph, okay? You could have used this graph. This is 50. If we did 1 over 50, we would get the same value, 0.020 molar. And then, of course, because it's second order, we need to square it. Okay, and once we do that, we get K is equal to 2.5 molarity to the -1 seconds to the -1.